Good morning students, welcome to online classes. In previous session we have discussed how to evaluate second order and third order determinant and how to calculate or how to evaluate minor and cofactor of a determinant. But in this session we have discussed some properties of determinant. So properties of determinants, that is first is if the rows changes to column and a column changes to row, then the determinant remains unchanged. The first property is if we changes rows into column or column changes to row, then the determinant remains unchanged. That means we take examples here. Suppose a determinant having three order A1, B1, C1 and 2, B2, C2 and 3, B3, C3. If we changes rows into columns, that means if we changing rows, first row changing to first column, that means A1, B1, C1, second row changing to second column, A2, B2, C2, A3, B3, C3, value remains unchanged. That means value of the left part of the determinant is also equal to the values of right part. That means if changing rows into columns of a determinant, the values of the determinant remains unchanged. So property number 1, we take examples here. Suppose 2, 3, 5, 7. If we solve, because it is a second order determinant, if we calculate, then we get 14 minus 15, that is equal to minus 1. If we, according to property 1, if we changes rows into columns or column changes to row, that means if we changes rows into column, that means 2, 3 changes to first column and second row changes to second column. If we calculate or we will solve, then we get 14 minus 15 and that is also minus 1. So if we changing rows into columns, that means the value will be unchanged or the values remains unchanged. That means the values are 1. Okay. Now proceed to property number 2. And the property number 2 is the interchange of two adjacent rows or columns the interchange of two adjacent rows or columns of a determinant change the sign of the determinant without changing its numerical values. Property 2 is the interchange of two adjacent rows or columns of a determinant changes the sign of the determinant without changing its numerical values. That means, suppose we take a third order determinant, that means A1, B1, C1, A2, B2, C2, A3, B3, C3. It is a determinant of third order, as you know, it is a third order determinant. If we interchange of two adjacent row means the two nearer row or columns first we have to discuss in rows. So interchange of two rows means the adjacent row of first row is R2 and adjacent row R2 is R1. You can say R1 or R3. So the nearer row is called adjacent row. So here if we changing adjacent row between R1 and R2, if we changing R1 and R2, that means we can write R1 in place of R2 and R2 in place of R1. That means we can write A2, B2, C2, A1, B1, C1, and that is A3, B3, C3. If we changes the interchange the two adjacent row, then sign of the determinant without changing. That means if we interchange between two rows, then we changes the sign because it has plus, or if interchange then we get negative. And here we changes R1 interchange R2. This is the sign of interchange. So here if we change R1 and R2, then we change the sign of the determinant. We change sign of the determinant, but without its numerical value. That means if the determinant having value is 5, then if we interchange, then value is minus 5. Okay. Similarly, if this determinant changes, suppose we changing R2 and R3, if we changing row 2 and row 3, if we interchange row 2 and row 3, that means here R1 is A2, B2, C2. If we changing R2 and R3, R2 and R3 means we can write R2 in place of R3 and R3 in place of R2. So here we can write A3, B3, C3, A1, B1, C1. And the sign will be minus of minus. That means plus. So the interchange of any two rows or any two columns, then changing its sign only, but without changing its numerical values. Suppose here we changes row to row. Now we take column to column. Another example. Take another example. So here this is a determinant of third order. If we changing, suppose column 1 and column 2. If we changing column 1 and column 2, because column 1 and column 2 are two adjacent columns. So if we changing C1 and C2, then we get, that means we can write C1 in place of C2 and C2 in place of C1. So we can write B1, B2, B3, and here A1, A2, A3, and that is C1, C2. And the sign will be negative because the value, the given determinant is positive. So the interchanging to adjacent column, then we change the sign only. Okay. If we interchange column 2 and in column 3, then what will be the result? If we changing column 2 and column 3, column 2 and column 3, that means if we changing, so here column 1 is B1, B2, B3. Okay. If we changing column 2 and column 3, that means we can write column 2 in places of C3 and C3 in places of C2. So we can write C1, C2, C3, A1, A2, A3. And the sign will be changed. That means here the value sign is negative. So negative of negative, that means positive. So according to property number property 2, if we changing two adjacent row or columns, then the determinant change the sign only without changing its numerical values. So this is the property 2, and next proceed to property number 3. And the property 3 is, if two rows or columns of a determinant are equal if two rows or columns of a determinant are equal, or you can say identical, then the determinant is 0. In this properties, or according to properties number 3, we can calculate determinant without solving a determinant. That means, according to properties 3, that two rows or columns of a determinant are identical. If two rows or any two columns are identical, then the determinant is 0. So, we take examples here. Suppose A1, B1, C1, A2, B2, C2, and A1, B1, C1. Suppose we take an examples. But in these examples, you see here R1, the values of R1 or elements of R1 is also equal to values of R3. So here you can write R1 is equal to R3 because the values are same in R1 and R3 are same. So we can directly write as 0 according to property 3. If two rows or any two columns are identical, then the determinant will be 0. So the values is 0. That is here reason is R1 and R3 are equal. Take another example. Suppose 2, 5, 7, 2, 4, 9, 8, etc. So, in these examples, we can directly write as 0. Why? Because in this determinant, here column 1 and column 3, elements of column 1 and column 3 are equal or identical. You can say identical. So, we can, if we solve this determinant, then we will also value is 0. If we solve according to how to evaluate or how to calculate third order determinant, in previous session, if we evaluate, then we get result 0. So, according to properties number 3, if here, according to properties number 3, that here two columns are equal, so it is 0. The reason is column 1 is equal to column 9. So, we take another examples. Suppose 1, 2, 3, 1, 2, 3, 1, 2. What will be the result of this determinant? It's also 0. Because we have any two rows or columns, but here all rows are same. Okay, so according to properties 3, you can write if two rows are same, third row is same or not. So the determinant is equal to 0. So it is the property 3. Now proceed to question property number 4. And the property number 4 is if a factor is multiplied with each element of a row or a column, then the determinant determinant will be multiplied with that factor. You understand these properties? No. Now we discuss about property 4. If a factor is multiplied with each element of a row or a column, then the determinant will be multiplied with that factors. So here we take an examples. Suppose we take an examples 3915. So it is a second order determinant. In this determinant, we take common. Can you common any rows or columns? Yes, we take common. In first row, we take common 3. So in determinant, we take common any rows or columns. But in a matrix, we take common with each elements. With every elements, we take common. But here in determinant, we take common any rows or columns. So in first row, we take common 3 only. So the first row will be 1, 3. As you take common 3, so here 1, 3. And the remaining part or R2 remains same because we take common only 3 on first row. So here we can write take common 3 from R1. So we take common only 3 from R1. So this is the result. Now take another example. Suppose 4, 8, 10, 5, 15, 25, okay, 9, 27, 18. So this is a harder determinant. So how to common or how to take common any rows or common columns. So here you can see in this determinant, in first row we take common and second row also we common and third row we take common. So here we take common 2 from first row. So if we take common 2 from first row, then we get 2, 4, 5. Similarly, if we take common 5 from R2, so we take common 5 from R2, that means we can write 1, 3 and 5. Okay. Similarly, we take common 3 or we take common that line, we can write 9. Then we take common maximum 9. So we take common 9 from R3. So we get 1, 3. If we calculate or you evaluate, then we get the answer, and this given answer is also equal. So in property 4, how to take common of a determinant. That means in this determinant, we take common any rows or columns, not every element of a determinant. Okay. So take common means any rows or column. Then how to multiply a factor of a determinant? Suppose we take common 2 ABCD. Okay. We can take a reverse of the determinant. Suppose 2 is a constant or 2 is a scalar. A 2 is multiplied to which elements? 2 is multiplied, that means we have previously know we take common any rows or columns. But if we constant multiply to rows or columns, so here 2 is multiplied to, so here the answer is, you can write if we multiply to first row, then we get 2A to B, CD. In determinant, 2 is not multiplied to all elements. In matrix, you can multiply all elements, but in determinant you cannot multiply to every elements. It can be multiplied any rows or columns. So here 2 is multiplied to first row, that means 2a 2 bits 3. This is your answer. Okay, or we can write, if we multiply to second row, so we get a b 2c 2d. This is also your answer. Or if we multiply first column, then we get the result 2a 2c bd. This is also your answer. Or if we multiply second columns, so we get a c 2b 2d. This is also your answer. So here the answer will be 4. You can be write any one of them. Okay. So in a scalar is multiplied to any determinant, that means it is multiplied to any rows or columns. Okay. So this is the property number 4. That means if a factor is multiplied with each element of a row or a column, then the determinant will be multiplied with that factor. That means we take common the element which is multiplied to whole determinant. Okay. Now proceed to property number 5. And the property number 5 is, if each element of a row or column, if each element of a row or column consists of 2 or more than 2 terms, then the determinant can be expressed as the sum of two or more determinant. So according to property number 5, if each element of a row or columns consists of 2 or more than 2 terms, then the determinant can be expressed as the sum of 2 or more determinants. So here we take examples to understand clearly. Suppose we take L1 plus M1 A1 B1, L2 plus M2 A2 B2, and L3 M3 S3. So we take a 3-order determinant, as you see. In column 1, you can see, in column 1, the addition of 2 elements here. So we can be expressed as a sum of each element of the determinant. That means we can write L1, L2, L3. So here you can see the first elements are L1, L2, L3. So here L1, L2, L3, and the column 2 and column 3 are normal. That means we cannot break at column 2 and column 3. So here at1, at2, at3, B1, B2, B3 plus. So why we write plus? Because here the value is addition of 2 elements. So here plus, so you can write plus here. Okay. Now the other part is, the first part is L1, L2, L3. can write. The other part is M1, M2 and M3. So you can write in first column M1, M2, M3, A1, A2, A3. The other columns are remain same because we can break only first column. We break in first column because in first column there are two elements here, addition of two elements here. So we can break them L1, L2, L3 of a one part and M1, M2, M3 is another part. So we can break into two determinants. If it contains negative, so we can be expressed in negative form. If we add, we can add. If we subtract, then you can be written it in subtract. Okay. So this is the properties 5, and next proceed to property 6. And the property 6 is very important. Properties. So property 6 is each element of a row or a column. Each element of a row or a column is increased or decreased by the corresponding elements of other rows or columns. So here this is an important property. So each element of a row or a columns is increased or decreased. Will be increased or decreased by the corresponding elements of other rows or columns. So here any rows or columns of a determinant can be increased or decreasing by the corresponding elements of other rows or columns. So here we take an example. Suppose we have to prove that determinant of 1, 1, 1, A, B, C and S square, B square, C square is equal to A minus B, B minus C into C minus C. So it is an important property, you say, and it contains 6 mark long question category questions. So how to prove this determinant will be A minus B, B minus C into C minus C. So according to property 6, here we can be increased or decreased by the corresponding elements of other rows or columns. So here get the solution. So first we take LHS part, that is 1, 1, 1 ABC, determinant of third order. Okay, if we solve this determinant as a direct process for evaluation of third order determinant process, so we get a result of the multiplication form, but we cannot solve this process. We cannot find the values of the factor form. Okay, so we can apply property 6. So here you can see in this determinant, first row, elements of first row are same or equal. So you will be subtract, then you get value 0. If a determinant contains maximum 0, then you will easily find the value of determinant. Okay, so here you can see in this determinant the first row of all elements are equal. So here the values of a row, so we can subtract column to column. If a determinant contains same elements of a row, then we subtract column to column. If all elements of column are same, then we can subtract row to row. Okay. So here in this determinant, in the first row, all elements are same. So we can write column to column. So we take some values. So we take column 2 and column 3, and in 2. So if we column 2, then we can subtract column 2 to column 3, and in column 3 we can subtract column 3 minus column 1. It's a cyclic process that we do know 1, 2, and then after 3. So it's a cyclic process, that means 1 minus 2, or we can write 2 minus 3, or we can write 3 minus 1. As you write in the first, then the similar process you can write in the second one. Okay. So here column 2 is, we write column 2 can be replaced as C2 minus C3, and column 3 can be written as column 3 minus column. So in this rule you can apply the second step. So here we can do changes in column 2 and column 3 here. Okay. So here column 1 is remaining same. So the column 1 will be 1a square. Okay. Now column 2 will be here the column 2 and this is column 3. We changing column 2 minus, we can subtract column 2 minus column 3. Then we get 1 minus 1, that is 0. B minus C, that is B minus C. Okay. And here we can write B square minus C square. Similarly, column 3, in places of column 3, we can write column 3 minus column 1. So here is column 3 and that is column 1. Okay. So you subtract column 3 minus column 1, then we get 1 minus 1 0, that is C minus A, and that is C square minus A square. So we apply the properties number 6. Now we get solve. Here 1a square, 0 b minus c. If we evaluate, we apply a formula b square minus c square. That we can write b plus c into b minus c. Okay. Similarly, 0 in third column we can write 0 c minus a, c plus a into c minus a. So here, as you see, in this determinant we take common in column 2. So which element or which factor is required, we take common. So you can see here b minus c will be common in column 2. So we take common b minus c from column 2, and c minus a take common from column 3. So here column 1 is remaining same because we cannot take common from column 1. So this is remaining same. So it is 1a square. Okay. So b minus we take common from column 2. So we can write 0. B minus we take common b minus c. So it is 1, and that is b plus c. Okay. Similarly, we can write c minus a take common from column 3. So we get 0, 1, and c plus c. Now, if we evaluate or calculate the above expression, so here b minus c into c minus a, we take a bracket here because we can evaluate it means here in this R1, here we can see the maximum 0, so we can evaluate directly. So here 1 into, as you know in previous session, how to evaluate or how to calculate third order determinant. So here we can expand in R1 along R1. So R1 is 1 0 0, and this side will be plus minus plus. So here 1 into row column will be deleting row and columns of the elements 1. Then we get 1 1 B plus C, C plus A. Okay, and that is the sign of negative, so minus 0 into तो 0 होगा, plus 0 into 0. So we cannot write this value because any element of multiplied with 0, that means it will be 0. So B minus C into C minus A. If we calculate, then C plus A minus B plus A. So B minus C into C minus A. If we break the bracket, so we get C plus A minus B minus C. So here we cancel the sign of C, so plus C minus C cancel. So we get B minus C into C minus A into A minus C. So this is the answer of this question. So in this process, we can be evaluated or prove the following problems. Because here the right hand side are in factor form. So in this factor, a question having factor form, then we apply property 6. So in this session we have discussed 6 properties of a determinant. This is a very important part of a determinant. So I hope in this session we have understand clearly. Have a nice day.